November 12th, 1942, Richmond, California. The metal scaffold shook beneath Henry J. Kaiser's feet as he checked his pocket watch for the third time in 5 minutes. The mid-morning sun reflected off the massive steel hull of the SS Robert E. Peary, throwing harsh light across the Richmond shipyard, where thousands of workers scurried in orchestrated chaos. The air carried the acrid smell of welding flux, machine oil, and salt water, the olfactory signature of modern shipbuilding. 4 days. Just 4 days since the keel had been laid, and now the nearly complete Liberty ship towered above the assembled crowd of military officials, government inspectors, and journalists. The spectacle before them represented the impossible, a 14,000-ton vessel constructed in less than 100 hours, when conventional wisdom held that shipbuilding required months, not days. Kaiser tucked away his watch and gripped the railing. His weathered face betrayed no emotion, but his eyes tracked every movement below as workers made final preparations for launch. His reputation, his shipyard's future, and possibly the trajectory of the Allied war effort hinged on the next 30 minutes. 3 minutes to launch, sir, called his assistant over the cacophony of pneumatic tools and shouted orders. Kaiser nodded without turning. The timing had to be perfect. The tides waited for no man, not even one who had rewritten the rules of industrial production. Rear Admiral Howard Vickery stood beside Kaiser, his naval uniform pristine amid the industrial grime. "Even seeing it, I can hardly believe it," he muttered. "When you promised a ship in 4 days, I thought you'd finally gone too far." Kaiser permitted himself a slight smile. "The Germans are sinking our ships faster than we can build them. We had no choice but to go too far." Below them, workers disconnected acetylene torches and moved scaffolding away from the hull. The Peary's frame, 441 feet long, 57 feet wide, with a 27-foot draft, stood ready. Its 2,700 horsepower steam engine was installed. 5 cargo holds prepared. Where traditional shipbuilding would have seen a half-completed hull after weeks of labor, Kaiser's revolutionary methods had produced a launch-ready vessel. The key had been modular construction, building large sections simultaneously in different locations, then bringing them together in a precisely choreographed sequence. What began as heresy in naval construction circles had become necessity as German U-boats claimed Allied shipping at devastating rates. A harsh whistle blast cut through the yard's noise. 1 minute remaining. Kaiser's mind flashed back to the audacious bet he'd made just 2 weeks earlier. During a meeting with Maritime Commission officials in Washington, he declared that his Richmond yard could build a complete Liberty ship in less than a week. The skepticism was immediate and universal. Traditional East Coast shipyards were celebrating cutting construction time to 40 days. Kaiser's own yards averaged 14 days. 4 seemed physically impossible, yet here they stood. The announcement came over the loudspeaker. 30 seconds to launch. Workers cleared the final staging areas. The massive hull, painted standard wartime grey, waited only for gravity and water. Kaiser's innovation wasn't just about speed. It represented a fundamental reimagining of how industrial production could work. 10 seconds! Kaiser felt the platform vibrate as spectators pressed forward for a better view. 5, 4, 3, 2, 1. The restraining blocks were knocked away. For a heartbeat, nothing happened. Then, with the groan of 15 million pounds of steel beginning to move, the SS Robert E. Peary started its slide toward the water of San Francisco Bay, carrying with it the vindication of Kaiser's vision and a revolution in American industrial capability that would help determine the outcome of a global war. November 12, 1942, Richmond, California. The metal scaffold shook beneath Henry J. Kaiser's feet as he checked his pocket watch for the third time in 5 minutes. The mid-morning sun reflected off the massive steel hull of the SS Robert E. Peary, throwing harsh light across the Richmond shipyard where thousands of workers scurried in orchestrated chaos. The air carried the acrid smell of welding flux, machine oil, and salt water, the olfactory signature of modern shipbuilding. 4 days. Just 4 days since the keel had been laid, and now the nearly complete Liberty ship towered above the assembled crowd of military officials, government inspectors, and journalists. The spectacle before them represented the impossible. A 14,000-ton vessel constructed in less than 100 hours, when conventional wisdom held that shipbuilding required months, not days. Kaiser tucked away his watch and gripped the railing. His weathered face betrayed no emotion, but his eyes tracked every movement below as workers made final preparations for launch. His reputation, his shipyard's future, and possibly the trajectory of the Allied war effort hinged on the next 30 minutes. 3 minutes to launch, sir, called his assistant over the cacophony of pneumatic tools and shouted orders. Kaiser nodded without turning. The timing had to be perfect. The tides waited for no man, not even one who had rewritten the rules of industrial production. Rear Admiral Howard Vickery stood beside Kaiser, his naval uniform pristine amid the industrial grime. "Even seeing it, I can hardly believe it," he muttered. "When you promised a ship in 4 days, I thought you'd finally gone too far." Kaiser permitted himself a slight smile. "The Germans are sinking our ships faster than we can build them. We had no choice but to go too far." Below them, workers disconnected acetylene torches and moved scaffolding away from the hull. The Peary's frame, 441 feet long, 57 feet wide, with a 27-foot draft, stood ready. Its 2,700 horsepower steam engine was installed. 5 cargo holds prepared. Where traditional shipbuilding would have seen a half-completed hull after weeks of labour, Kaiser's revolutionary methods had produced a launch-ready vessel. The key had been modular construction, building large sections simultaneously in different locations, then bringing them together in a precisely choreographed sequence. What began as heresy in naval construction circles had become necessity as German U-boats claimed Allied shipping at devastating rates. A harsh whistle blast cut through the yard's noise. 1 minute remaining. Kaiser's mind flashed back to the audacious bet he'd made just 2 weeks earlier. During a meeting with Maritime Commission officials in Washington, he'd declared that his Richmond yard could build a complete Liberty ship in less than a week. The skepticism was immediate and universal. Traditional East Coast shipyards were celebrating cutting construction time to 40 days. Kaiser's own yards averaged 14 days. 4 seemed physically impossible. Yet here they stood. The announcement came over the loudspeaker. 30 seconds to launch. Workers cleared the final staging areas. The massive hull, painted standard wartime grey, waited only for gravity and water. Kaiser's innovation wasn't just about speed. It represented a fundamental reimagining of how industrial production could work. 10 seconds! Kaiser felt the platform vibrate as spectators pressed forward for a better view. 5, 4, 3, 2, 1. The restraining blocks were knocked away. For a heartbeat, nothing happened. Then, with the groan of 15 million pounds of steel beginning to move, the SS Robert E. Peary started its slide toward the water of San Francisco Bay, carrying with it the vindication of Kaiser's vision and a revolution in American industrial capability that would help determine the outcome of a global war. October 1942, Richmond Shipyard No. 2. The Richmond Shipyard hummed with activity as Kaiser assembled his team to plan the impossible. In a small office overlooking the massive building ways, production managers, engineers, and foremen hunched over blueprints spread across folding tables. The standard Liberty ship design, with its 3 cargo holds forward, 2 aft, and midship house containing crew quarters, was dissected into hundreds of components, each assigned to specific teams. Traditional shipbuilding is like building a house brick by brick, Kaiser explained, tapping the blueprints with calloused fingers. We're going to build entire rooms elsewhere, then bring them together at the end. The key innovation wasn't new. Kaiser's yards had been using modular construction for months, but the scale and precision required for a 4-day build demanded taking the concept to its extreme. The SS Robert E. Peary would be divided into 250 prefabricated sections, each built simultaneously in separate fabrication shops before being transported to the building way. Every inch of steel, every bolt, every weld must be ready before we start the clock, Clay Bedford, Kaiser's operations manager, told the assembled supervisors. Once we lay that keel, we don't stop for anything. Throughout late October and early November, the Richmond yards transformed into a complex machine. The workforce was reorganized into 3 shifts of 5,000 workers each, ensuring round-the-clock construction. Welders practiced joining sections together, refining techniques to reduce time without sacrificing strength. Prefabrication buildings operated at maximum capacity, producing hull sections, deckhouses, and internal components that would be needed during the main assembly. At the heart of Kaiser's strategy was a simple yet revolutionary approach. Workers would be waiting for parts, not parts waiting for workers. Every component of the 14,000-ton vessel was staged in precise sequence. Cranes were positioned strategically to minimize movement time. Welding stations were duplicated to prevent bottlenecks. One of the most significant innovations involved the installation of the ship's 2,500 horsepower steam engine. Traditionally, engines were installed after the hull was complete, a process that could take days. Kaiser's team built a massive rolling platform that would allow the entire engine assembly, a 140-ton behemoth, to be rolled into place and secured in hours rather than days. The logistics were staggering. Over 700 tons of pre-assembled hull sections waited near the building way. 60 miles of welding would be required. The electrical systems alone contained 28 miles of wiring. Every component was labelled, catalogued, and assigned to specific teams. "What if something goes wrong?" asked a Maritime Commission observer who had arrived to document the attempt. "Something will go wrong," Bedford replied matter-of-factly. "We've built redundancy into every critical path. If a crane fails, we have backup. If welding equipment breaks, we have spares ready. If weather turns, we have temporary structures that can be erected in minutes." Workers were briefed extensively. Many had been building Liberty ships for months or even a year, but the compressed timeline required perfect execution. Practice drills were conducted, with teams timing how quickly they could move hull sections into place and secure them. As November began, Kaiser's innovation extended to the workers themselves. Special food service stations were established around the building way, allowing workers to eat without leaving their stations. Medical teams stood by to handle injuries immediately. Even bathroom facilities were positioned strategically to minimize time away from work. By November 7th, everything was ready. The building way stood prepared, with the keel supports in place and the first hull sections waiting nearby. Tools were organized in mobile stations that could follow the work as it progressed along the ship. The 3-shift rotation was established, with detailed handoff procedures to ensure no momentum would be lost during transitions. At precisely 12:01 a.m. on November 8, 1942, Kaiser gave the order to begin. The keel of the SS Robert E. Peary was laid into position. The clock started on what most shipbuilding experts still considered impossible: 4 days to transform steel plates and prefabricated components into a fully functional Liberty ship. November 8th-10th, 1942, Richmond Shipyard No. 2. The first hours were the most critical. Under the harsh glare of floodlights, the night shift moved with precision as the keel plates of the SS Robert E. Peary were secured and welded into position. The clock started at 12:01 a.m. on November 8th, and within the first hour, the outline of the ship's massive spine was taking form: 441 feet of steel that would become the backbone of a vessel designed to carry 10,500 tons of cargo across submarine-infested waters. By sunrise, when the day shift arrived to relieve the night workers, the ship's profile was already recognizable. The first prefabricated hull sections, massive steel components weighing up to 40 tons each, were being hoisted into position by cranes. The handover between shifts took exactly 7 minutes, a choreographed exchange of tools, progress notes, and immediate priorities that ensured no momentum was lost. "We're 45 minutes ahead of schedule," announced the shift supervisor, checking marks on his clipboard against the master timeline. The workers from the outgoing shift, faces streaked with sweat and grime, nodded with tired satisfaction before heading to the canteen for hot food before sleep. The rhythm established itself quickly. Welders moved in coordinated teams, their torches creating showers of white-hot sparks that rained down on the workers below, who shielded themselves with asbestos blankets while continuing their tasks. The sound was deafening. The constant percussion of hammers, the hiss of welding torches, the grinding of metal on metal, and the shouted orders that somehow rose above the industrial cacophony. 12 hours in, disaster threatened when one of the main cranes developed a hydraulic leak. The massive lifting arm froze while holding a 35-ton hull section suspended 80 feet above the building way. Work below had to stop while engineers scrambled to address the failure. Kaiser, who had been monitoring from a temporary office adjacent to the site, arrived immediately. "How long to fix it?" he demanded. 4 hours minimum," replied the maintenance chief. Kaiser shook his head. "We don't have 4 hours. Bring in the auxiliary crane from Yard 4. The backup crane arrived within 30 minutes, and work resumed with only a 47-minute total delay. The master schedule was immediately revised, with subsequent tasks compressed to make up the lost time. By midnight of the first day, the lower hull was nearly complete. The prefabricated bow and stern sections were being prepared for attachment. Below decks, teams were already installing bulkheads that would separate the ship's 5 cargo holds. The building way resembled a human anthill, with workers swarming over every section of the growing vessel. The second day brought new challenges. Mid-afternoon, a critical welding jig, a specialized tool that held steel plates in precise alignment, failed structural tests. Without it, the deck plates wouldn't align properly with the hull. The lead engineer, awake for nearly 30 hours straight, redesigned the jig on the spot, sketching a modified version on blueprint paper while fabricators stood by. The new jig was built, tested, and implemented within 90 minutes. News of the attempt had spread. By the end of the second day, reporters gathered at the yard's perimeter. Government officials arrived to witness what many still considered impossible. Workers from other shipyards came during their off hours, standing in silent observation of a construction pace that defied conventional wisdom. As dawn broke on November 10th, the 48-hour mark, the Peary's hull was complete. The superstructure, the deckhouse containing the bridge, crew quarters, and navigation equipment, was hoisted into place in a single piece, a 60-ton module that had been fully constructed off-site, complete with electrical systems, plumbing, and even furniture bolted to the floors. The installation of the main engine became the day's critical path. The 140-ton power plant, a triple-expansion steam engine capable of driving the ship at 11 knots, was rolled into position on its specially designed carriage. 50 workers swarmed over it, connecting steam lines, securing mounting bolts, and aligning drive shafts with the precision of surgeons. When the evening shift arrived at 4 p.m. on November 10th, the Peary was recognizable as a ship. The hull was complete. The superstructure was in place. The engine was installed. What remained was a sprint to complete outfitting, testing, and final welding before the planned launch just 44 hours after work had begun. November 10-12, 1942. Richmond Shipyard, No. 2. The third morning arrived with a bone-chilling fog rolling across San Francisco Bay, shrouding the shipyard in a grey haze that diffused the floodlights into eerie glowing orbs. The temperature had dropped overnight, forcing welders to work with fingers stiffened by cold, their breaths forming small clouds that mixed with welding smoke. Despite the conditions, the pace never slackened. Hour 52 brought the most dangerous phase of construction, the installation of the Peary's 3 massive cargo booms. Each steel arm weighed over 5 tons and had to be precisely positioned by crane operators who could barely see through the fog. One wrong move could kill workers below or cause structural damage that would derail the entire timeline. The yard fell unnaturally quiet as the first boom was hoisted skyward, workers holding their collective breath until it settled perfectly into its mounting. "Get those securing bolts in now," barked the foreman, his voice cutting through the silence. "We've got 2 more to go and no time to stand around admiring our work." By mid-afternoon, the Peary's physical structure was complete. The vessel now faced its most critical challenge: systems testing. Electrical circuits that would normally be checked over several days had to be verified in hours. Pump systems required pressurization tests. The rudder mechanism needed calibration. Failure of any major system would mean missing the deadline. At hour 62, the main electrical switchboard failed a continuity test. Somewhere among the miles of wiring lay a fault that had to be located and repaired immediately. Kaiser himself joined the electrical team, reviewing wiring diagrams spread across makeshift tables near the stern. "We don't have time to test each circuit individually," the chief electrician announced. "We'll have to divide the system and use parallel teams." 4 electrical crews began working simultaneously from different points, methodically tracing connections until, 43 minutes later, a young woman named Sarah Phillips, one of the thousands of female workers who had answered the wartime call, located a cross-connected junction box near the engine room. The repair took 7 minutes. Testing resumed. As dawn broke on November 12th, the final day, the Peary was recognizable as a complete Liberty ship. The hull gleamed with fresh paint, applied by teams working from scaffolding and bosun's chairs suspended along the vessel's sides. The name SS Robert E. Peary was stenciled across the bow in white block letters. Hour 78 brought Admiral Vickery back to the yard, accompanied by Maritime Commission inspectors tasked with certifying the vessel as seaworthy. Their presence added pressure to workers already pushing the limits of endurance. Many had worked double shifts, catching sleep on cots set up in fabrication buildings when their replacements failed to arrive due to transportation issues. "We'll need to test the anchor windlass," announced a commissioner, consulting his inspection checklist. "Already completed at 0400, responded Bedford, handing over a clipboard with signed test results. "Every system on your list has been tested and documented." The Admiral raised an eyebrow, but nodded approval. The paperwork was being processed as rapidly as the construction itself. By hour 85, all that remained was final preparation for launch. The launching way, the inclined ramp that would guide the Peary into the water, was greased with tallow. Restraining blocks were positioned to hold the massive vessel in place until the ceremonial moment. The tide tables were consulted repeatedly. The launch would require perfect timing to ensure sufficient water depth. Spectators began gathering around the shipyard, government officials, journalists, competing shipbuilders, and thousands of civilians who had heard about the attempt. Kaiser's workers from other shifts returned to witness the culmination of their efforts. A makeshift reviewing stand had been erected overnight. At precisely 3 p.m. on November 12, 1942, at the 87-hour mark of construction, Vickery gave his official approval. The SS Robert E. Peary was complete, its construction verified, its systems operational. 9 hours ahead of the 96-hour challenge. Kaiser, who had barely slept in 4 days, allowed himself a small smile as he climbed the platform for the launch ceremony. Beneath the platform, workers who had made the miracle possible pressed forward for a better view, their faces showing exhaustion but also unmistakable pride. The traditional champagne bottle was presented. A Navy band played. The crowd grew silent as the countdown began. When the signal was given, the restraining blocks were knocked away, and the Peary, 14,000 tons of American industrial prowess, began its slide toward water, moving with gathering momentum until it hit the bay with a massive splash that sent water 20 feet into the air. the impossible had been accomplished. A Liberty ship built in less than 4 days. November 1942, present day. As the SS Robert E. Peary settled into the water of San Francisco Bay, its impact on wartime shipbuilding was already rippling outward. Within hours, newspapers across America carried the story of the 4-day wonder, a vessel built in less time than it took to sail from New York to London. Kaiser had not only won his audacious bet, but fundamentally altered perceptions of what American industry could achieve. The Peary's construction had been documented in meticulous detail by Maritime Commission observers, who verified every milestone. The official record: 4 days, 15 hours, and 29 minutes from keel laying to launch, a construction pace nearly 20 times faster than the industry average just 18 months earlier. Maritime Commission Chairman Admiral Land, initially skeptical of Kaiser's claims, now became his strongest advocate. What Kaiser has demonstrated isn't just a shipbuilding record, Land told reporters gathered at Richmond. It's a revolution in industrial production that will help win this war. The immediate effect was a complete revision of Liberty ship production targets. In early 1942, a goal of 200 ships had seemed ambitious. By the end of 1943, American shipyards would deliver 1,661 vessels. Kaiser's methods, the modular construction, the prefabrication techniques, the precise scheduling and logistics, spread rapidly throughout the American shipbuilding industry. The Peary itself entered service in December 1942, just weeks after its record-breaking construction. Over the next 3 years, it would complete 15 transatlantic crossings, delivering nearly 150,000 tons of war material to Europe. Despite being constructed at unprecedented speed, the vessel proved remarkably durable, surviving multiple encounters with German U-boats that sank slower ships in the same convoys. In March 1944, the Peary's hull plates withstood the concussive force of a torpedo that exploded 50 yards off its starboard side. The welds held. The structure maintained integrity. The vessel that skeptics had dismissed as a publicity stunt demonstrated its worth in the cauldron of combat. By war's end, Kaiser's Richmond yards alone had built 747 ships. The U.S. Maritime Commission's emergency shipbuilding program, transformed by Kaiser's innovations, produced 5,777 vessels, enough to overcome the U-boat threat and sustain Allied forces on multiple fronts. The long-term implications extended far beyond shipbuilding. Kaiser's techniques, particularly his approach to modular construction and precisely scheduled logistics, became fundamental principles in modern manufacturing. The post-war economic boom of the 1950s was built in part on production methods pioneered during the Peary's construction. Kaiser himself continued innovating. In 1945, he established Kaiser Permanente, a healthcare system originally designed to serve his shipyard workers that would grow into one of America's largest medical providers. His Kaiser Aluminum Corporation revolutionized aircraft production. The Kaiser Frazer Automobile Company briefly challenged Detroit's Big Three with innovative designs. Yet the legacy of the 4-day ship extended beyond Kaiser's personal empire. The Japanese automotive revolution of the 1970s, which transformed global manufacturing, drew heavily on principles that Kaiser had demonstrated at Richmond. Toyota's just-in-time production system, having parts arrive precisely when needed, rather than warehousing large inventories, echoed the logistics Kaiser used to build the Peary. Modern shipbuilding continues to employ modular construction, though with computer precision that Kaiser's engineers could only dream about. Today's massive container ships, some exceeding 1,300 feet in length and carrying 24,000 containers, are built using descendants of Kaiser's techniques. South Korean shipyards construct vessels of unprecedented size by assembling massive prefabricated sections, just as Kaiser's teams did at Richmond. The SS Robert E. Peary itself served until 1963, when it was finally scrapped after 2 decades of commercial service. By then, the Liberty ships, once the emergency solution to a wartime crisis, had been replaced by more modern vessels. But the revolution in industrial production that Kaiser sparked with his impossible challenge had permanently altered global manufacturing. In 1982, 40 years after the Peary's launch, the American Society of Mechanical Engineers designated Kaiser's Richmond Shipyard No. 2 as a historic mechanical engineering landmark. The citation noted that Kaiser's innovations fundamentally changed the relationship between time, resources, and production possibilities. The most enduring legacy may be the mindset Kaiser demonstrated, the refusal to accept conventional limitations, the belief that radical innovation could solve seemingly insurmountable problems. From modern module-based construction to just-in-time manufacturing, from emergency disaster response to today's rapid deployment medical facilities, the echo of Kaiser's 4-day ship continues to ripple through American industry 8 decades after its improbable launch into the waters of San Francisco Bay.